Solving equations with rational exponents. All right? So at some point during the process of solving these equations, we will raise both sides to a power. Anytime you raise both sides to a power, you must check your answer. All right? So here, x to the 3/2 equals 8. And there's various ways you can do this. You can treat this as the square root of x cubed and square both sides and then take the cube root. Or you can say, okay, look, I have x to the 3/2. Let's say x to the 3/2 equals 8. And we're going to raise this side to the 2/3 power and this side to the 2/3 power. This is one way to do it. I'll work this one two different ways so you can kind of see and pick which way you like better. Right? This is a little bit shorter. So if you have this, and the reason this works, a power to a power, you multiply those. When you multiply them, the 2's and the 3's both divide out and they become 1's. So this is x equals 8 to the 2/3 power. That means what? Well, what's the cube root of 8? That's going to be 2, and then you're going to square it. So x equals 4. Okay? X equals 4. Now, because I raised both sides to a power, I technically should check this. So if I check it, let's check it here. If I check this, I'm going to get 4 to the 3/2 equals 8. Well, what's the square root of 4? It's 2. So this is 2 cubed. What's 2 cubed? 8. Does 8 equal 8? Yep. All right, so x equals 4 here. All right. X equals 4 here. What if I wanted to do this a different way? What if I said, hey, Mr. Guest, I know that x to the 3/2 over 8 is the same thing as the square root of x cubed equals 8. And then I want to say, okay, let me square both sides. Okay, you can do this. So this is going to be x cubed equals, right? Because if you square a square root, you get what's underneath there. X cubed equals 8 squared is 64. X cubed equals 64. Then you say, well, let me come back and take the cube root of this side, which is what we just did in one step instead of 2 here, but this is the same thing. Cube root of x cubed, when it's odd, when these are odd, then it's exactly x. When they're even, you got to be careful about this. When they're even roots, you get a plus or minus, okay? You get an absolute value, all right? So you got to be careful. So cube root of 64 is 4, right? Cube root of 64 is 4. And so we end up with the same answer we got using a different method. So whichever way you like better. All right. I'm gonna likely do this version over here. Right? So then x plus 5 to the 2/3 equals 4. So we're going to say x plus 5 to the 2/3, and we're going to raise it to the 3/2 equals 4. We're going to raise it to the 3/2. Whatever I do to one side, I got to do the other, right? So these divide out and become 1's, right? So that just becomes x plus 5 equals 4 to the 3/2. What is the square root of 4, right? The bottom number's the root. What is the square root of 4? It's 2. 2 to the 3rd power. So x plus 5 equals, not 1, 8. And then we subtract 5 from both sides, and we get x equals 3. And if we check it, right, if we go check this, check 3 plus 5 to the 2/3 equals 4, right? We're plugging 3 in there. That's going to be 8 to the 2/3 equals 4. What's the cube root of 8? It's 2. 2 squared is what? 4. 4 equals 4. Check. So then x equals 3 is my answer, right? X equals 3 is my answer. So 8x to the 5/3 minus 24 equals 0. It's much better if you can get this x to the 5/3 by itself. Okay? So you can raise both sides to a power. So we're going to, same thing we did with radicals. Okay? So, or same thing you would do with radicals. So plus 24 on both sides. So 8, I don't want to mess with the original equation. 8x to the 5/3 minus 24 equals 0. Anytime I'm going to come back and check it, I don't want to mess with the original like that. I want to do this. So this is going to cancel out 8x to the 5/3 equals 24. Divide both sides by 8. So then x to the 5/3 equals 3. And now Now that I have x to the 5/3 equals 3, I can say, okay, this is going to be to the 3/5. Oops. 3/5. And this divides out and I get x equals 3 to the 3/5 power. So, I mean, I guess if I try to figure that out, I don't know what the 5th root of 3 is, but 3 cubed is 27. So, I mean, I guess if you wanted to write it this way here, it's the same thing. Okay, but I don't know why you couldn't leave it 3 to the 3/5 power. So if I wanted to check it, right, x equals 3 to the 3/5. I want to leave it that way when I check it just because I think that's going to be easier to check. You get 8 and then 3 to the 3/5 raised to the 5/3 power. Nope, not equals. Minus 24 equals 0. So, right, this went in for x, and only x was raised to that power. So 5 and 3 divide and become 1s. They all divide out until we're left with 8 times 3 minus 24. That's 24 minus 24, and that's going to be 0. And then we bring down the other 0, and that checks out. So my answer here is this. And if you wrote it this way, that's fine. I just think that's more difficult to check in this scenario. But it's the correct answer. The 5th root of 27 is the same thing as 3 to the 3/5 power. It's the same exact thing. All right, so that one was a little bit crazy because we didn't get 2 or 8 or 16 or 12 or 35 or whatever. We got 3 to the 3/5 power. All right, so x minus 3 square root of x minus 40 equals 0. So this kind of equation doesn't look like it has a rational, except for the fact that this is really what? X to the 1/2. So that's why it's in here, okay? So when we have these, right, anything that's quadratic looking, see, this is not quadratic because it's not x squared, but it kind of looks like it, right? It's got 3 terms. And then here's the kicker. What is the power here? 1. What is the power here? 1/2. Is that not double that? Yes, it is. Anytime the first power is twice the middle power, you can use the quadratic form here. So this is list method because the 1 is out front, okay? So when I do my 2 parentheses, I don't need x. I need the square root of x, okay? So the square root of x times the square root of x is really the absolute value of x. But because we're going this direction, we should be okay, and we're going to check our answers when we get through anyway. So because the square root of x is already in here, you don't have to worry about x being negative, is what I'm saying. Because of how this problem is set up, x equaling a negative number is not going to work itself out when you check it if you get something. So you can worry about absolute value if you want to, but here, if you remember to check it, it's going to work itself out. So here I want the factors of 40, 1 and 40, 2 and 20, 3, 4 and 10, 5 and 8. Well, the ones that subtract to give me 3 are 5 and 8. So I'm going to put the 8 and the 5. Doesn't matter what order. The signs are different. I know both those are negative, but that means they're different in the answer. So the bigger number gets a negative. The bigger number gets a negative. All right? So 8 gets a negative, 5 gets a positive. If you don't like those signs, go watch my list method video in factoring. All right? It will tell you where we get those signs from. And then we take each one of these and we set them equal to 0. Let's see what happens here. Let's see. We get the square root of x equals 8 because we're going to add 8 to both sides. And then how do I finish solving that? Square it. X equals 64, right? And technically the square root of x squared is, well, if it was the other way, I should say. If it's this, that's where the absolute value of x comes in for sure. But because we started with the square root of x and we squared it, we know that x underneath the radical can't be negative. There's no need for a plus or minus there, right? So then on the next one, we're going to do the same deal here. We're going to subtract the 5. We get square root of x equals negative 5. And then we're going to do what? Square both sides. And really, wait a minute. The square root of x equals negative 5. when is the square root of a number going to be negative? See, I'm just going to take this and say, you could go through this, but when you check 25, it should not work. It should not work. But right here, I'm saying this falls apart. Because when can you take the square root of a number and get a negative? Not in real numbers you can't. So this doesn't work itself out. So the only answer I get is 64, so I need to check what? Again, if you went through that and got 25, when you go check it, you should find out that 25 doesn't work. You'll get 25 minus 15, which is not 40. All right? So here, x equals 64, and we've got to check it. And we get 64 minus 3 times the square root of 64. Right, so let me put those in parentheses, I'm plugging them in. Minus 40 equals 0. So this is 64 minus 3 times 8 minus 40 equals, so 64, I can go and put that together. 64 minus 40 is 24, minus 24, and that's 0, right? 0 equals 0, it checks out. So x equals 64 is my final answer there. All right? Again, if you didn't catch this right here, if you didn't catch this and you square, but let's just run through it real quick. And so x equals 25, right? That's what you would get. You would get 25. So we can get rid of these because it'll be easier to. So then what if you checked 25? You get 25 minus 3 times the square root of 25 minus 40. And you get 25, well, let's see. 25 minus 40 is negative 15 minus 3 times 5. You get negative 15 minus 15, you get negative 30 equals 0, and that's no good. So if you went ahead and didn't catch that, you would get it whenever you check both sides. I mean, when you check the answer, okay? If you didn't catch it right there and you went ahead and solved it, you should catch it as soon as you get to that point where you check it, all right? But here the only answer is 64, all right? And then you have x to the 2/3 minus x to the 1/3. This is exactly the same problem as before, except we're cube roots. The one before, x to the 2/2, 2 over 2 is 1, so we just showed x. We didn't have a radical or a rational exponent or anything right there. All right? So x to the 2/3 minus x to the 1/3. So is this power twice this power? Yes, it is. So when I get ready to factor it, this is list method. There's a 1 in the front again with 3 terms, no GCF. So when I get ready, it's going to be x to the 1/3 and x to the 1/3. It's always this middle term whenever it's half of the first power. All right. So then when you do that, I want the factors of 6, 1 and 6 or 2 and 3 that do what? Subtract to give me 1, the coefficient there. Don't worry about the negative. We'll get that later. It's going to be 2 and 3. So 2 and 3. So then when I do that, I get what? I get bigger number gets a negative. That's what it says, right? So 3 gets a negative, 2 gets a positive. Once I do that, I say x to the 1/3 plus 2 equals 0, or x to the 1/3 minus 3 equals 0. And then I'm going to subtract 2. X to the 1/3 equals negative 2. Now remember, this x to the 1/3 is like what? It's like the cube root. But cube roots are not the same thing as square roots. Odd roots can be negative. So don't just dismiss this. Take this and raise it to the 3rd power, right? Because that's like over 1. Those 3's divide out. So we get x equals negative 2 times negative 2 times negative 2 is negative 8. When you cube a negative number, you get what? A negative. So don't sit there and go, oh, yeah, the negative goes away. No, it doesn't. It does not. It does not go away. It stays there. So then we're going to do the same thing to the next one. We're going to add 3. X to the 1/3 equals 3. That's a 1. All right. And then we're going to, let me fix that. And then we're going to do what? Cube both sides. Cube this side. Cube this side. So x equals 27. So we have 2 answers. X equals negative 8 or x equals 27. And you may get more than that. You don't want to just get 2 answers. So then we're going to check, because we raised both sides to a power, we want to make sure. So we're going to have negative 8 to the 2/3 minus negative 8 to the 1/3. And the negative 8 here has to go in parentheses because you're taking a number and raising it to a power. And that negative gets raised to a power 2. If you just wrote this, it's wrong. I don't care if I write it, I'm wrong, you write it, you're wrong, your teacher writes it, they're wrong. That's not correct. It must have that on there or it's wrong, period. I don't care. It's wrong. It just is, okay? I'm not trying to be ugly, it just is. The parentheses matter here. All right, so then I did not give myself enough space here. I can tell you right now, I did not give myself. I'm going to have to get real close with that. All right? So the cube root, this means the cube root of negative 8 is what? Negative 2, still in parentheses, squared, minus, same thing here, negative 2 to the first power minus 6 equals 0. So negative 2 to the squared is going to be 4, and then minus a negative 2 is plus 2, because that's to the first power, minus 6. 4 plus 2 is what? 6 minus 6. So it's 0 equals 0. So that one checked out, didn't it? Wow. That one checked out. So we already know, if we have an answer box down here, if we have an answer box, we already know that x equals negative 8. And that's good. That's a good one. We don't know about the next one, though. We've got to check it. So 27. So we say 27 to the 2/3 minus 27 to the 1/3 minus 6 equals 0. Okay? So again, the cube root of 27 is what? Because I have that there and I have that there. That's 3. So this is going to be 3 squared. Now this is a positive number. So if you don't put it in parentheses, that's okay here. If you want to emphasize it with parentheses, you can do that. But it's not necessary because it's positive. This number is necessary. It is wrong if it's not there. Okay? So, I don't know, we don't like to call things wrong, but that's wrong. Okay? Minus 3, the cube root of that to the first power, which I don't need the 1 there, equals 0. So 3 squared is 9, minus 3 minus 6 is 0. This is 6. I'm bringing my 0 down as we go. 0 equals. And guess what? That one also checks out. So not only is my answer negative 8, but it's also comma 27. So x equals negative 8 or 27. They both work here. All right? But we have to check them to make sure. The reason we do is because on the last problem, if you missed the whole negative 5 equals the square root of x thing, when you got 25 and checked it, you'd find out, oh, it doesn't work. All right? So x to the 2/5 plus 5x to the 1/5 plus 6 equals 0. This same thing. 2/5 is twice of 1/5, right? So whenever I get ready to do this, this is list method 1 again. Okay? And by the way, this could be done with a 3 in the front and be bottoms up or something crazy. You know, it could be different. It could have different things going on here. So this is going to be x to the 1/5. So let me make my 5 a little better. And then times x to the 1/5. Okay? And equals 0. And I want the factors of 6 that do what? Add to give me 5. Don't tell me 6 and 1. They got to add to give me 5. 2 and 3. And then the signs are both positive. Okay? So plus and plus. So we're going to say x to the 1/5 plus 3 equals 0. Or x to the 1/5 plus 2 equals 0. And I don't like this 5 right here. That's not much better. There we go. That's better, I guess. So now we're going to solve each one of these minus 3 from both sides. We get x to the 1/5 equals negative 3. And again, with it being an odd power, negatives are okay. So raise both sides. That's supposed to be a 5 to the 5th power. Those divide out because it's over 1. So x equals negative 3 to the 5th. Well, a negative number to the 5th power, think about it. The first 2 negatives is positive. The next 2 negatives is positive. That's 4 of them. You got 1 negative left over. That's negative. So I always take care of my signs. You can go negative 3 times negative 3 times negative 3 if you want to. Okay? So, and then my 3s. 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81. Or you can go 3 times 3 times 3 is 27. Times 3 is 81. I think it's a little harder. So anyway, I'm at 81, but that's 4 9s. And 81 times 3 is 243. That's one of those powers that you need to file away in your memory bank. If you don't readily know that 3 to the 5th is 243, you need to readily know it. It needs to kind of be committed to memory. Just so when you see 3 to the 5th, oh, 243. Okay. So then, that's one of my answers that I'm going to check in just a minute. So I'm going to subtract 2 here. X to the 1/5 equals negative 2. And then I'm going to raise both sides to the 5th power. And again, this is over 1, so those divide out. So x equals, again, it's negative. 2 times 2 times 2 times 2, 5 times is 32. Okay? 2 times 2 is 4 times 2 is 8, times 2 is 16, times 2 is 32. Again, 2 to the 5th is 32. You need to know 2 up to probably the 10th power, okay? So it's 1,000, 2 to the 10th, 1,024 kilobytes on a computer. Anyway, all right. So not exactly 1,000. It's powers of 2. So now we get x equals negative 243 or x equals negative 32, and we are going to check both of them. We are going to check both of them. All right. So when we check them, I'm just trying to use all my colors. We're going to check it in the original. So negative 243 to the 1/5 plus 5 times negative 243 to the 1/5, and that this first one was not the 1/5. So let me fix that. I'm sorry. This was not the 1/5. Some of y'all were screaming at the computer screen. Oops. Moved the wrong thing. Oh my goodness. Seriously? Come on. Yeah, there we go. To the 2/5, right? Then get rid of that. And then plus 6 equals 0. So the 5th root of negative 243, we know what that is. That's negative 3. Negative 3 squared plus 5 times negative 3 to the 1st plus 6 equals, right? So negative 3 squared is 9. Negative 3 to the 1st power is negative 3. So 5 times negative 3 is minus 15 plus 6. 9 minus 15 is negative 6 plus 6, which is 0. Bring down your 0. Boom, it checks out. So in my answer box down here, I already know what? I already know x equals negative 243. Now, what I don't know is, do I put comma negative 32 or not? So let's come over here and do that. Let's check this one. This is going to be negative 32 to the 2/5 plus 5 times negative 32 to the 1/5 plus 6 equals 0. So we know what the 5th root of negative 32 is because, look, we raised it to the 5th power, negative 2, right? So this is going to be negative 2 in parentheses. It's got to be in parentheses because it's negative. Negative 2 squared plus 5 times negative 2 to the 1st plus 6. So this is going to be positive 4. Negative 2 to the 1st, that's negative 2 times a positive 5 is negative 10 plus 6. So negative 6 plus 6, which is 0. So we didn't have any here that didn't check out, right? So then we put in here comma negative 32 because that one works as well. So x equals negative 243 and negative 32. So I hope this helps you with equations that have rational exponents in them.